Welcome learners. This is Dr. T. Gangaram, lecturer in statistics, SVA Government College, Srikalahasti. In this video lecture, we will discuss the fifth unit of numerical analysis, numerical integration, derivation of general quadrature formula. By using general quadrature formula, we will derive trapezoidal rule, Simson's 1/3 and Simson's 3/8 rules. Numerical integration is used to approximate definite integrals. It is useful when the function is given in tabular form. Integration is difficult analytically. When these situations, we can use numerical integration instead of usual integration. It is based on interpolation of f of x values. The basic idea behind the numerical integration is, let us assume I is equal to a to b f of x dx. Divide this integral into n equal parts first. The range is a to b. Maximum value is b here. A is minimum value. We need to divide this integral into n equal parts. We need to decide the number of parts to be divided first. If n is decided, we can find the interval of difference h is equal to b minus a by n. Then by substituting the interval, the initial value x naught is the beginning value, x naught plus h. We are finding here b minus a by n, a plus h, x2 is a plus 2h, so on. N is the last value, that is nothing but b, or otherwise x naught plus nh. So by substituting these x naught values, we can get y naught values from the given function. If we substitute x1 in the given function, we will find y1 value by using the given function. Similarly, first we divide the total parts by adding x0 plus interval, x0 plus 2 interval, like that. Then by substituting the x0, x1, so on values in the function, we can find y0, y1 and yn values. The change of variable is done. Let u is equal to x minus x0 by h. By differentiating both sides, du is equal to du by dx is equal to, there is no u term here, so 1 divided by h remains, this becomes 0. This is equal to dx is equal to h, dx is equal to h into du. By substituting x is equal to x naught in this, we will get x naught minus x naught, this is 0. Similarly, by substituting x is equal to xn, x naught plus nh, that is equal to u is equal to n. Hence, x naught plus nh f of x dx is equal to, we already find dx is equal to h into u, h comes out, f of x is equal to y, h into 0 to n y du remains. The Newton forward formula, we know that y is equal to y naught plus u into delta y naught, so on. We derive the general quadrature formula by using Newton forward formula. Substitute this Newton forward formula y in the function. Integral f of x dx is equal to h into 0 to n, the series, Newton forward formula series into du. Substitute the Newton forward formula here. Now integrate term wise. Here we have 1 here, integral 0 to n, 1 into du, it becomes n. Integral 0 to n, u into du is equal to n square by 2. Integral 0 to n, u into u minus 1 by 2 du is equal to, by substituting n, we will get here n minus 0, this becomes n. n square by 2 minus 0. So here 0 to n, the third term, 1 by 2 into u square minus u into du, 1 by 2 into n cube by 3 minus n square by 2. First integrate and substitute the maximum and minimum values. We will get these terms. This is the fourth term, next term, and this is the next term. We will get the terms by integrating first. Substitute these integrals in the function 0 to x naught to x naught plus nh f of x dx is equal to h into, this is the first term, into y naught n square by 2 into delta y naught n 1 by 2 into n cube by 3 minus n square by 2 into delta square y naught, and so on. This is called as general quadrature formula. Now, by using this general quadrature formula, we will get different formulas. First, trapezoidal rules. Substitute n is equal to 1 in the general quadrature formula by ignoring the highest differences. I is equal to h into y naught plus n is equal to 1 by 2 delta y naught. We know that by definition of delta y naught, forward difference operator, y1 minus y naught. Instead of delta y naught, we can use y1 minus y naught. This is I is equal to 1 by 2, 2 comes here, 1 by 2 y naught plus y1. This is the first for two terms only. The general form is, you need to remember this formula, trapezoidal rule. For n intervals 0 xn x naught to xn f of x dx is equal to h by 2 into first term plus last term y naught plus yn plus 2 into remaining terms. Here area approximated by trapezoidums. This is the problem example for trapezoidal rule. For application of trapezoidal rule, evaluate 0 to 6 x square by 1 plus x square dx. The trapezoidal rule is given by a to b f of x dx is equal to h by 2 into y naught plus yn first term plus last term plus 2 into remaining terms. A to b f of x dx is equal to, this is approximately equal to, we need to decide the number of intervals first. Let it be n is equal to 6. So the first term is equal to b term is 6 here. Look here, b 6 minus a, 6 minus a divided by n is equal to, let us assume n is equal to 6 here. Then our h becomes 1. By substituting x naught is equal to 0, x naught plus h, x naught plus h is 0 plus 1, 1 plus 1, 2, like that. We can find x naught, x1, x2, x3, x4, x5, x6 terms, and then by substituting f of x naught is equal to 0 here, f of x1 is equal to, by substituting 1 square by 1 plus 1, 1 by 2 is equal to 0.5. Like that, we need to construct the x naught and y naught values by using the function. These are the values, and the integration, inner term in integration, summation y I is equal to 4.103. I is approximately equal to 1 by 2. This is in the formula. 1 is h is equal to 1 here. 2 is in from formula. First term 0, last term 0.973 here, and the 2 into remaining terms total. This becomes 9.173 by 2. Our y is approximately equal to 4.589. The answer is 4.589. Let us test it for by using the integration. We know that integral x square 1 plus x square dx is equal to 1 minus tan inverse x. Here 0 to 6, x is 6 here, 6 minus tan inverse 6 is tan inverse 6, that is equal to approximately equal to 6 minus tan inverse 6 is equal to, from tables, 1.405, nothing but 4.595. Trapezoidal rule gives a very close approximation. Next is Simson's one-third rule. Substitute n is equal to 2 in general quadrature formula by ignoring the higher order terms from delta cube y naught we ignore. This is our formula. Substitute delta y naught is equal to y1 minus y naught. Delta square y naught is equal to, we are all know that, y2 minus 2y1 plus y naught. This is for three terms. Trapezoidal Simpson's one-third rule for three terms, h by 3 into y naught plus 4 into y1 plus y2. You need to remember this Simpson's one-third rule general for n intervals. X0 to xn f of x dx is equal to h by 3 first term plus last term plus 4 into 3 multiples plus 2 into remaining terms. This is the Simpson's one-third rule. You need to remember for solving the problems in the examination. Here n must be the even. We need to decide the n as even number so that we can use all the terms for calculation of the given function. Evaluate 0 to 2 2x by 1 plus x power 4 dx by using Simpson's one-third rule with h is equal to 0.25. Here in the examination itself, they are given the interval of difference as h is equal to 0.25. If they are not given, we need to decide the number of intervals first, and by using the formula h is equal to b minus a by n, we can find h value. Now, Simpson's one-third rule is given by integral a to b f of x dx approximately equal to h by 3 into, this is in the from the formula, first term plus last term plus 4 into sum of all odd terms plus 2 into sum of all even terms. Here, by using the h is equal to 0.25, we can divide the area into 8 equal parts. So, this is the formula for 8 intervals, h by 3 first term plus last term plus 4 into odd number of observation, odd multiples, odd numbers plus 2 into even number multiples. H is equal to 0.25, n is equal to 2 minus 0 by 0.25, that is 8. This is the formula for n is equal to 8. Here 0, 0.25, we need to add 0.25 to 0. We will get the x terms first. Then by using the x terms, we need to find f of x terms by from the function 2x by 1 plus x power 4. Substitute. We need to find the inner terms first, summation of odd terms, and this is summation of even terms, and we substitute h is equal to 0.25 by 3 from formula first term and last term plus 4 into the 3 multiples and 2 into remaining terms. So this is nothing but approximately equal to 1.461. We need to check for the by using the integration. Integral 2x by 1 plus x power 4 dx is equal to tan inverse x square. This is equal to tan inverse x square. 2 here, 2 square is equal to 4, nothing but 1.326. It is slightly overestimates the value. We overestimate, 1 point is overestimated. So last rule is Simpson's 3/8 rule. Put n is equal to 3 in the general quadrature formula. We will get I is equal to h into 3 into y naught plus 9 by 2 into delta y naught plus 9 by 4 into delta square y naught plus 3 by 8 into delta cube y naught. We assume three terms here, delta cube up to 3 delta cube only. By substituting delta y naught, delta square y naught and delta cube y naught in the form, we will get for n is equal to 3 and up to delta cube only, we will get I is equal to 3h by 8 into y naught plus 3 into y1 plus y2 plus the remaining term y3. The general rule is x0 to xn f of x d is equal to 3h by 8 into first term plus last term plus 3 into plus 2 into 3 multiples first and plus 3 into the remaining terms. We need to Remember this formula for examination purpose. Here the condition is n is the multiple, n must be a multiple of 3. We need to take 3 interval n is equal to 3 or n is equal to 6 or n is equal to 9, like that. Evaluate 0 to 6 1 by 1 plus x dx using Simpson's 3/8 rule. This is the formula for Simpson's 3/8 rule. F integral 0 x naught to xn f of x dx is equal to 3h by 8 first term plus last term plus 2 into 3 multiples and 3 into remaining terms. Choose n is equal to 6 multiples of 3, then h becomes 6 minus 0 by 6 is equal to 1. We need to decide the x terms first, 0 to 6, and after finding the x terms, we substitute the x terms in the function by substituting the x terms in the function f of x values become, and apply formula 0 to 6 1 by 1 plus x dx is equal to 3 into h is equal to 1 here, first term plus last term plus 2 into 3 multiples and plus 3 into remaining terms. This is our simplification. 2.1536 approximately. Final answer is 2.1536. Comparison of rules is the trapezoidal is linear approximation and Simpson's one third is parabolic, more accurate, and 3/8 rule is Simpson's 3/8 rule is cubic approximation. The accuracy order is by using Simpson's one third rule we can get accurate results. Simpson's 3/8 rule is lesser accurate than Simpson's one third, and trapezoidal rule is more lesser accurate than these two. And let us conclude the lecture. Numerical integration converts integration into algebraic sums. It is based on interpolation polynomials and it is widely used in engineering and sciences. We derived general quadrature formula, and based on that finite difference table, accuracy increases with higher number of intervals. Thank you.